Good day, ma'am. Logic. Logic statement. Every language contains different types of sentences, such as statement, question, and commands. For instance, is the best today is a question. Go get the newspaper is a command. This is a nice car is an opinion. Denver is the capital of Colorado is a statement of fact. A statement is a declarative sentence that is either true or false, but not both true and false. A simple declarative sentence has a simple sentence structure consisting of a subject and a predicate. Example of a declarative sentence in the simple form include: my dog is sick, pizza is the best, Sam is smart. Example number 1, identify statement. Determine whether each sentence is the statement. A. Florida is a state in the United States. And letter B. How are you? And letter C. X plus 1 equals 5. Solution. A. Florida is one of the 50 states in the United States, so this sentence is true and it's a statement. And letter B. The sentence, how are you, is a question. It is not a declarative sentence, thus it is not a statement. And letter C. X plus 1 equals 5 is a statement. Logic, connective, and symbols. Statement. Not P, connective, not symbolic form, not P, type of statement, negation. Statement, P and Q, connective and symbolic form, P and Q, type of statement, conjunction. Statement, P or Q, connective or symbolic form, P or Q, type of statement, disjunction. Statement, if P then Q, connective, if then symbolic form, if P then Q. Statement of types of statement, conditional. Statement, P if and only if Q, connective, if and only if, symbolic form, if P then only if Q, types of statement by conditional. Truth tables, equivalent statement, and tautologies, and conditional and biconditional. Truth tables. A truth tables give the truth value of compound statement for all possible true values of the simple statement that make it up. We will consider to be true tables for negation and conjunction, the disjunction, and the conditional. Truth tables for negation given by not P and represented by not P. The truth value is a simplest reserve. Truth table for negation. P, true, false, not P, false, true. Conjunction, P and Q. Truth table for conjunction. P, true, true, false, false. Q, true, false, true, false. P and Q, true, false, false, false. Note: A conjunction P and Q can only be true if both simple statement P and Q are true. If their P and Q or both are false, the final statement is false. Example: I am Radford student and I am in math. 116 can be true if you are both a Radford student and indeed taking math 116. Disjunction P or Q. Truth table for disjunction: P, true, true, false, false. Q, true, false, true, false. P or Q, true, 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 false. Note: a disjunction P or Q can only be false if both simple statement P and Q are false. If either P and Q or both are true, the final statement is true. Example: I will go my math 116 class or stay in bed is only false if you do not go to your math 116 and do not stay in bed. Number 4. Conditional. If P then Q. Truth tables for conditional. P, true, true, false, false. Q, true, false, true, false. If P then Q, true, false, true, true. Note: a condition P then Q can only be false if the hypothesis P is true and conclusion Q is false. Example: suppose P equals you attend class, Q equals you will pass, and we form the conditional P then Q that says if you attend class, then you will pass. This conditional can only be false if you attended the class but still did not pass the class. Construction truth tables of compound statement involves knowing the value of the four basic truth tables: negation, conjunction, disjunction, and conditional. These are summarized at the top of the next page. Basic truth tables. Truth table for negation. P, true, true, not P, false, true. Truth table for conjunction. P, true, true, false, false. Q, true, false, true, false. P and Q, true, false, false, false. Truth table for disjunction. P, true, true, false, false. Q, true, false, true, false. P or Q, true, 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 false. Truth table for conditional. P, true, true, false, false. Q, true, false, true, false. If P then Q, true, false, true, true. Equivalent statement. Two statements are equivalent if they both have the same truth values for all possible truth values of their component statement. That is, if the final result of the truth tables are the same. The conditional and related statement. Converse, inverse, and contrapositive. Conditional statement. Converse, inverse, and contrapositive. If P then Q, if Q then P, or the reverse. If not P, then Q not sign change. If not Q, then not P, order, reverse, and sign change. Example: determining related conditional statement. Given the conditional statement, if I live in Wisconsin, then I shovel snow. Determine each of the following. Letter A, the converse. Letter B, the inverse. And letter C, the contrapositive. Solution. Letter A, if I shovel snow, then I live in Wisconsin. And letter B, if I don't live in Wisconsin, then I don't shovel snow. And letter C, if I don't shovel snow, then I don't live in Wisconsin. Symbolic arguments. An argument is valid when its conclusion necessarily follows from a given set of premises. An argument is invalid or a fallacy when conclusion does not necessarily follow from the given set of premises. Determine whether an argument is invalid. Write the argument symbolic form. Compare the form with the form that are known to be either valid or invalid. If the argument contains two premises, write a conditional statement of the form premise 1 or X premises 2. Conclusion. Construct a truth table for the statement in step 3. If the answer column of the table has all truths, the statement is a tautology, and the argument is valid. If the answer column of the table does not have all true, the argument is valid. Example: identifying common fallacies in arguments. Determine whether the following argument is valid or invalid. If it is snowing, then we put salt on driveway. It is not snowing. We do not put salt on the driveway. Argument and Euler diagrams. The purpose of the Euler diagrams is to create a visual representation of each of the aspects in logical arguments so that the conclusion may be clearly evaluated. Generally, one oval is constructed to present each set described in the argument, and X is used to represent solitary units. Logical arguments. A logical argument is made up of premises, assumptions, laws, rules, widely held ideas, or observation. A conclusion. Valid and invalid arguments. An argument is valid if the fact that all the premises are true forces the conclusion to be true. An argument that is not valid is invalid. It is called fallacy. Arguments with universal quantifiers. Several techniques can be used to check the validity of an argument. One visual technique is based on Euler diagrams. That's all. Thank you.